Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Swiss Cheese by GDC. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. There are going to be black holes, which are nullifiers, where we need to place 9 black holes, one in each row, column, and box. And digits may not repeat on black holes. For the purposes of the clues, black holes have a value of 0. And we also have white holes that correspond with the black holes. And these are doublers, where we need to place 9 white holes, one in each row, column, and box. And digits, again, may not repeat on white holes. So we can't have repeats on white hole cells either. And for the purposes of the clues, white holes double the value of a cell. And white holes and black holes can never share the same cell. So white holes and black holes are different digits in the puzzle. Okay. Or different cells in the same row and column and box. They can never be the same cell. We have killer cages, where digits in cages cannot repeat, though values can. And values within a cage sum to the clue in the top left. And a killer cage must contain an equal number of black and white holes, but that number may be 0. So the values of the cells in this cage must add up to 25. But digits cannot repeat, so keep that in mind. And we can have a black hole, but we have to have the same number of black and white holes in these cages. So you could have 1 white hole and 1 black hole here. That would be valid. Same with this. This could be 1 white hole or 1 black hole, or it could be 0 black holes and 0 white holes in these cages. But they have to have the same amount of white holes and black holes in the killer cages. We have teleporting little killers, where clues outside the grid with arrows give the sum of digits along a diagonally traveling path starting in the cell pointed at by the arrow. And this path only ends when it reaches an edge of the grid. When the path enters a black hole cell, sum of digits. When the path enters a black hole cell, it teleports to the white hole cell with the same digit, maintaining the direction of travel of the original path, and including the values of both holes in its sum. And the path must visit the same number of black and white holes, but that number may be 0. So for example, let's say this was traveling along this path, and then say that this was a black hole. We're going to make the black holes red and the white holes green. So say this was the 5 black hole here. And we say we had the 5 white hole be there. then the values on this path would be these 4, then it would teleport to here, plus these 3. So then the values along this path specifically would add up to 32, if that were the case. And that includes the value of the white hole and the value of the black hole. And the path can only visit the same number of black holes and white holes in this path. So you cannot have it visit more white holes than black holes or more black holes than white holes. We also have clues outside the grid without arrows. So just these, the 10 and the 2 here and the 15 here. Give the sum of the digits between the holes in the row. Oh, these are called hole sandwiches. Clues outside the grid without arrows give the sum of the digits between the holes in the row or column, not including the holes. So basically, say we had a white hole here and a black hole here, the sum of these two digits would have to add up to 10, because the digits between the hole must sum up to the number that's outside of the grid without an arrow pointing. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. 3 digits can never add up to 25. So we're going to have a black hole and a white hole in this cage. What can the white hole be as a double? We could have 9 doubled, obviously. We have 1 white hole, so that's a value of 0. So we could have 9 doubled. We could have 8 doubled. We cannot have 7 doubled. So 9 doubled would have to be with 7. So we guarantee this has to have a 9, I think, because 9 doubled is 18, plus 7 is 25, and then we have 0. 8 doubled is 16, plus 0, and then plus 9 is 25. So one of these has to be a 9, guaranteed. We don't know what the digit in the black hole is, though. The digit in the white hole has to be 9. Or, no, that's not true. The digit in the white hole has to be 8 or 9 here. Also, this path here and this path here, it's either going to be 1 digit, which is a 3, or you're going to have to teleport into a black hole, because you can only have one of these digits be a 3. The other one has to be a black hole. So one of these digits is a 3. The other one is a black hole. And it cannot be 2 because the value of the white hole, which it would have to be part of the path, would be 2 times 2, which is 4, which is too big. So this has to be a 1-3 pair here in row 1. And then the must get to a 1 somewhere on the edge of the grid. We don't know where. Because, no, that's not true. It cannot go to the edge of the grid. It has to go to a digit with the 1. So that's a value of 2 times 1, which is 2, and then another 1. Interesting. So it has to go across a boundary and then reach the edge of the grid. So if it's 1 here, it would have to be 1, 1 there, or 1. So where are the okay, it cannot, if this is 1 and it's the black hole, obviously none of these can be 1 anymore. So then you would have to go 1 and then 1 here, and 1 and 1 here. So that would be the case if this were 1. And then one of these would be the white hole. If it goes 1 there, again, none of these can be 1. So to end on a 1, you can't be anywhere here on the edge of the grid. You have to be going diagonally to the left and down. Oh, I guess... So you could have one... No, you cannot have 1 and 1 here because they're in the same box. They have to go across boundaries. So then you would have 1 here and 1 here. So one of these two is a black hole. And then one is not. So this is a blue-red pair. And one of these is guaranteed to be a white hole. We don't know which. A 4-1 specifically. That means this cannot be a white hole here. Either way, we have to have a 1 be either going that way or that way, or this way or this way, which means we guaranteed have a 1 in this box, not in this cage, which means to add up to 8, we cannot have 3 unique digits. So we also have to have a black hole and a white hole in this cage, which eliminates white holes in this cage totally, because this is 1 white hole and 1 black hole per box also. So 1 has to be one of these white holes going in some direction to here. So it has to go to one of these two. This can't be the white hole. These cannot have black holes or white holes in the box because we know there's 1 of each here. 1 cannot be doubled. It could be 2 doubled with 4. Could be 3 doubled with 2. Or it could be... It can't be 4 doubled because that's 8 already. So we're guaranteed either way, the 2 has to be one of these 3 digits. And there are no more black or white holes in this column either, because we have 1 each in this cage. Okay. Between the white hole and the black hole has to be the value 2. And it can only be 1, 2. So therefore, this cannot be a black hole. Because then 2 is not available in this box to be there. And 2 has to be essentially one of these 2 digits. And one of these 2 digits is the black hole. So this is not black hole here. One of these is the black hole. That must have 2 with it. So if we have... That's a black hole there. It goes that way. So this is white hole. So then that would have to be black hole here. If this is black hole there, that would have to be white hole, so then that would have to be black hole here. That means the rest of column 1 cannot contain a black hole. Same with the rest of column 9. That means these can't be black holes. Because... So they can't also be a white hole. Because if you go to a white hole, if you enter a black hole, you'll always get to another white hole there. And that would have an unequal amount of black and white holes along the path for the little killer, teleporting little killers. And they have to be the same number of black and white holes that you visit. That's why these can't be black or white holes for that reason. We don't know which one of these is green, obviously, is the white hole, and we don't know which one of these is the black hole. None of these are black holes and white holes. And there's no way, if this goes all the way through, it has to have, that would be at minimum 1, 2, 3 plus 1, 2, 3, which is 12, which is too big. So we have to have a black hole here. So one of these two is going to be a black hole. What about this? Two cannot be the extra digit here. So 2 is going to have to, because of this whole sandwich. So 2 is going to have to be either in the white hole or the black hole. And obviously it can't be the black hole because we require the 2 to be part of the sandwich, part of the killer cage sum, right? If you don't have 2 doubled, you have to have 3 doubled with 2 as a normal digit, but that can't be possible. So 2 has to be the white hole here, and 4 has to be the non doubled digit value. So 2 doubled times 2 is 4, plus 4 is 8. And the reason why is the 2 in this whole sandwich has to be a singular 2, and it cannot be here, so it must be outside of the box because 2 is guaranteed to be in this cage here. So 2 has to be in the white hole here. And then the other one is a black hole, which we don't know. So this becomes a green-red pair, white hole, black hole pair. Same with this. Hmm. Um... 34. Oh. Hmm. This can't be 1, 2, 3, or 4 because of the 1, 3 pair in the row and the 2, 4 guaranteed in the column. So it's 5 through 9 there. This could be the 2 black hole here. What else black hole can you have? Everything from 1 through 4. 1, though, the black hole is guaranteed to be one of these, so it can't be 1. So we could have 2 through 4 here. I don't think any of these can be... Can we have this... Well, first of all, it has to go to a black hole here at best. That means this would be 3... assuming this doesn't go to reach a black hole here, it would have to reach a black hole here. So that would be guaranteed to be 3 doubled, at least. Because 1 can't be here because of 1 in the box. Has to be one of these two. Also, we have 1 already as a black hole. This can't be 2 as a black hole because 2 is the white hole here to be doubled in value. So it could be 3 as a black hole here, but then it would necessarily have 6 in value for the white hole anywhere else. So that would be 6 plus whatever digit is there, which is not 1 through 4. It would have to be 5 at least. It's too great. So one of these two is going to be a black hole. Obviously, 1 cannot be the doubled here. We could have 1 through 3 as the or 2 through 3 as the black hole here. So one of these is going to be 2 or 3 as the black hole. One of these is 2, 3, 4 as the black hole. Hmm. 17, 32. Hmm. These digits remaining in box 8 are 3, 5, 6 through 9. 3 and 5 through 9. If this is the black hole, that means this can't be the black hole. This would have to be the black hole here. We couldn't have a black hole here. Okay, so how would this work? So if this were the black hole, we don't have a black hole here. That's a white hole, which is a 2. That means this would not be white hole. It's black hole there. Black hole would eliminate black hole here. This obviously would not be a 2. So we cannot have the 2 as a black hole here. It would have to be 3 as a black hole here. And therefore, it would add up to 6. This would be then 1 and 2 at minimum, assuming that this was not a black hole. So even if this were a black hole, the problem is if it went through that way, that would still be too big, assuming that this was not a black hole. So we know... We don't know anything about this. This has to be a black hole, which means this cannot be black hole here, which means this is black hole here. So this is 2 or 3 as a black hole. This is 2, 3, or 4 as a black hole. We have to have the white hole add up to 15. Or sorry, the difference between the holes here add up to 15. So this cannot be white hole here or black hole, obviously. This can't be white hole or black hole here. So this could be white hole. Any of these 3 could be white holes there. So this is black hole there, black hole there. This is guaranteed to be at least 4. So this has to be 3 or less. Hmm. Right, 2 times 2 is 4. 7 minus 4 is 3 at least, at most. 2 times 2 is 4. This could then be 6 here. Potentially. Hmm. Okay. Um... So this teleports to something. Okay. Okay, what happens if this is 3? So if this is 3, that means we're guaranteed a 6 on the other end for value. That means this has to be 1. So this can't be 1 there. It's 3, which is not the what black hole. So this has to be the black hole there, which means this can't be black hole here. So this must be black hole here, which means this must be white hole here. This is 2 in value. This would have to be 1 and 1. So this would not be white hole here. We'd have 1 and 3. This would have to be 1. Oh, we have a contradiction. No, this is fine. It goes teleport there. Okay, that's fine. So that's done. That's done. So that, never mind. So this can't be 3 here. No 1 here. This would have to be 3 somewhere as a white hole. And it would have to end on the end of the grid. Could be here. This is white hole, so no white holes here, or black holes. You could have a 3 there. You could have 3 there, 3 here, 3 any of these. 3 would be here, so 3 would have to be one of these two. One of these would be a white hole. Hmm. Oh. If we had the 3 there, this does not add up to 32 with a single digit and then 6 in value. So we cannot have 3 be any of these digits here. Therefore, the 3 as the white hole would have to be one of these two, which means this couldn't be white hole. It would be black hole, which means this can't be black hole. It'd be white hole, so that would be 2. One of these would be white hole. It can't be 6 plus 2 digits is not going to add up to 32. Can we have a white hole here and then these? Well, we could go to a black hole there. Technically, no, this can't be a black hole. So this would not be able to get to another black hole. It would be 3 digits plus 6. Is that possible? I think so, right? 9, 8, and 9? Uh, 9, 8, and 9 adds up to 26 plus 3. So that is possible. Interesting. So this can never be 2. If this is 2, that can't... Okay, so this is guaranteed to be 1 and 3 as a pair. Interesting, because if this is 2, this has to be essentially a 3 as a black hole, but then the value of the doubled 3 on the white hole would be 6. 6 plus 2 already is 8. So we have a 1-3 pair here also. Interesting. But say we made this a 2 then. If this is 2 as a black hole, this would have a value. It cannot have a 2 here as the white hole, because then this would be white hole there. 2 cannot be here, so this must be 2 going there, which is between the black hole and the white hole, so these are not black and white holes. Which means this has to be 1. This is black hole, so no black hole there. So that's a 3 by itself, which makes that 1, which makes that 3. This is black hole. It has to be 3, 2. That's 4 in value, and it has to end there. So this has to be 2 as the white hole there, which means this is not white hole. It's black hole. This is 1 then. So far, this is fine. Then we have no white hole here. So white hole has to be here in this box because there's no other place for it. Black hole cannot be here or here, so black hole has to be there. So that's potentially possible. No 2 or 3 here, so this would have to be 4. Interesting. So we could have 1, 4, 1, potentially. But that doesn't work. Because if we try to have 1, 4, and then 4 doubled with the 1, where is it going to have that 1? 1 can't be here, 1 can't be here. So it's not going to be able to end going down to the right in any of these cells. And then it's not going to be able to end at all. So therefore, this must be then 2, which must have 4 as the white hole. Cannot be here. Cannot be here because of where the white holes are. It could be the white hole here. Or there, potentially. Well, we know there's a white hole here to be adding up to 15. So then the white hole would have to be one of these two, which would be 4. So that is possible also. Interesting. Okay. So one thing we do know is none of these can be black or white holes. One of these two is guaranteed to be a white hole here. So we have to have a white hole in one of these 3. That means we have a white hole in one of these 2, guaranteed. So none of these can be white hole or black hole, because we have a guaranteed black hole there. This can't be white hole or black hole, so those are empty there. Same with this. This is going to be white hole here. This can't be white hole, because that difference between the holes is going to be 0. So this cannot be white hole. So this must be either 3 here. It cannot have 4 digits in between the white hole adding up to 10, because one of these is 2 or 3. So we could have white hole here, white hole here. None of these can be white hole. It can't be black hole because black hole's there. So one of these 2 is white hole. This can't be black hole or white hole, so one of these 2. This is not black hole or white hole there. So this must be a black hole, white hole pair here, which eliminates black hole and white hole in the rest of the column. This is white hole, so this can't be white hole here. It's black hole, which means this can't be black hole here. It's white hole, so 9 cannot be here. The white hole here, which is double value, can only be 8 or 9. If it's 9 here, that's 18 plus 7, adding up to 25. If this is 8 here, this has to be 9 there. Okay. That means we don't have black holes or white holes in the rest of row 4 because we have already both of them already countered. That leaves this as white hole here. So the difference between this must add up to 10. So no 2, 3, 5. We have to have a 1 here. So either this is 2 and that's 3, or this is 1 and that's 3. So either way, this is 3. Adding up to 10 with no 3 could be 1, 2, 7. No 2 here. 1, 4, 5 with no 4 here. Or 1, 3, 6 with no 3 here. Okay. So one of these two is green, and one of these two is red. We don't know which. We do know in column 8 one of these is a 2. What else do we know? This is not 2, 1, 2, or 3. It's 4 through 9. We do know one of these 3 has to be a 1, because there's no other place for it. We know one of these 2 has to be, so it's either this one or this one is the white hole. So this can't be white hole here, which means where's the white hole in box 4? It must be there. So this is either going to be a 2, or it has to be a 9 here. Because if this is going 3 here, this has to be the only place for 3, where this satisfies going down this way and ending. Because 3 can't be here if this is 1 and 3. That would make 3 there. This is 1 as a black hole. But the problem is this wouldn't go up anymore. So it has to extend to here. So this is guaranteed to be 2 or 9. We just don't know which. Because 9 plus 9 plus 8 is 26, plus 3 doubled is 6, which is 32. And that's how that would work there. We don't know which one is the red hole here. If this is green, this is red. So if this is green, that's red. This is green and red here. Otherwise, this is green and red. Either way, this can't be anything. So red can be... If this is green, this has to be red here. If this is red, this has to be green here, right? Obviously. So, and we know one of these 2 is green. This is guaranteed to be green. That eliminates white holes in the rest of the column. We know one of these 2 is guaranteed to be black hole. So the rest of the column 1 cannot be a white hole or black hole. This is green here, so this cannot be green or red. It's blue. No green or red there, so that's blue. So one of these 2 is the white hole in this column. Okay. Huh. Yeah, and this has to have a 1 because we cannot have 2, 3, and 5 adding up to 10 here because this is 2 or 3. So... Okay, this is a white hole. If it just goes straight through, it would have an unequal number of white and black holes. So therefore, this must hit a black hole before that. So this is black hole, which means this can't be black hole. Where's the black hole in this box? It must be these 2. Must be black hole here, which means this is not white hole. That's white hole. So this cannot be white hole, black hole, which means This is between the white hole and black hole must be the 2, so this is 2, which makes that 3. This is 1 and 1 going that way. This must be 1 going to 3 doubled. 1 eliminates 1 here, so that's 3, which makes this 1. That's 3 in the corner. This is not black hole, that's white hole. Or sorry, normal. And this is black hole here. So it goes 1 to 1, 1. This has to be 3 as the white hole. It's the only place where this will add up to 32. So then this is 9, that's 9 and 8. So 9 cannot be here. This is white hole, so this can't be white hole here. That's black hole. That means this is not black hole here. It's white hole, and it must be the 2 doubled. This is 3. This can't be 3 anymore. It's 2 or 4. This can't be 1. If we go 2, so no more 9 here. So one of these, this can't be 1 or 1. 9 has to be one of these two. No more 8 here. So 3 there, 1, 1, 1. That adds up to, so this is 1 doubled. That's 2 plus 1 is 3. 3 obviously ends there. Three cannot be in the black holes because we have 1 and 3 now in the black holes. We have 1, 2, 3 here. Cannot go 6 and then 2 doubled because it still continues down this way. Can it actually ever be 2 here? 3 and 2 doubled is 7. Plus at minimum 3, and then minimum 3. So that's not going to work. So this has to go to 4 doubled, which means this is 2 and 4. We have to go somewhere where 4 is on the edge going, which is only the single digit going down to the left or right. So it has to be here. So that's 4. That means we cannot have 4 here. This can't be 1. So we have 2, 5. This can't be 1, 3, and 6 anymore. It's 1, 2, 7 or 1, 4, 5. So if it's 1, 4, 5, this has to be the 4, so that's not 5. Otherwise, it could be 1, 2, 7 here. 4 has to be one of these two digits. It cannot be the white hole here, so it has to be here in row 6. So this is 4, which makes this 1. That's 5. 1, 4, and 5 adding up to 10. We don't know about that. So this cannot be white holes. Available are 5 through 9. This can't be 5, so 6 through 9 there. This can't be 8. So 5, 6, 7, 9 as possibilities. We have 8 and 9 as a possible white hole there. This can't be black hole because of black hole in the column, so this is black hole there. Oh, so this goes that way. Okay, so we have black hole there. No more black or white holes in this column. Black hole here, which means where's the last black hole? It's there. That means these can't be black hole or white hole. This can't be black hole or white hole. Neither can these. Okay, so we have 2 and 4. That's 8. 4 times 2 is 8 plus 2 is 10. So this is satisfied. That's satisfied. 1, 3 there by itself. It reaches the end of the grid. 1 doubled is 2 plus 1 is 3. 1 plus 3 doubled is 6 equals 7. And then it ends. So this is done. 9 plus 3 doubled is 6, 15. Plus 9 is 24, plus 8 is 32. We have the difference here between the holes is 2. Difference between the holes here is 10, 1, 4, and 5. We still have this. This can't be 1 or 3. We have at least 2. So this has to be less than... What can it be? We could potentially have a 2 there. So this is done, this is done, this is done. We are not done with this. This goes, it teleports there. Can you have 4 digits adding up to 15 between the holes without 2 and 3? The answer is no, because 1, 4, 5, and 6 is at minimum 16, which is too big. So this cannot be black hole or white hole. This is white hole here, which means this can't be white hole. That's nothing. And this must be white hole there. So these 3 digits add up to 15. Without 2 and 3. These can't be 1, 2, 3, 4, 5, so this must be 6 through 9. Because of 1, 3, 4, and 5 in the box. I think this has to be 6, 8, and 1 here, then. Yeah. So that's 1. This is 6, 8. As a pair, that eliminates 6 and 8 in the rest of the column. So we have just 4, 5, 7, 9 remaining in the column. This can't be 4 because we already have 4 in a white hole. So this is done as the whole sandwich. What do we have left? We have this diagonal, this diagonal. I think that's it. Huh. And that's just normal Sudoku. I guess with this. Remaining digits of box 6 are 2, 7, 9. This can't be 9 because of 9 in the column. So we're guaranteed one of these is a 9 here. 9 eliminates 9 in the rest of the box here. So 9 has to be one of these 2 digits here. Okay. This can't be 9. It can't be 1, 3, or 4. It could be 2, no 5 because 5 in the column. It could be 2, 6, 7, or 8. But can it be 8? 8 doubles is 16 plus 2 is too large. So 2, 6, or 7. This could be a lot of different numbers. 2, 5 through 9. Okay. Remaining digits of row 8 are 3, 5, 6, 7, 8. No 8s here because of 8 in the box. No 3 here because of 3 in the box. This can't be 3 because we already have 3 in a black hole. So where's the 3 in row 8? It has to be one of these 2, which eliminates 3 in the rest of the box. Remaining digits of box 7, we have 1, 2, 4, 5, 6, 7. 4 cannot be either of these. 2 can't be either of these because of 4 in the row and 4 in the column, 2 in the row. 1 cannot be either of these because of 1 in the column. This can't be 2, or 1 in the row. This can't be 2 because of 2 in the column. Remaining digits of row 6, 2, 6, 7, 8, 9. No 2 here because of 2 in the box. So where's 2? 2 has to be here. That means this becomes a 7, 9 pair, which eliminates 7 and 9 in the rest of the column. So this can't be 7. It's then 2 or 6 here. 6, 7, 8, and 9 here. No 8 here because of 8 in the column. No 9 here because of 9 in the column. This can't be 1 or 4 as the black hole because we already have 1 and 4 as the black hole. This is, yeah, so this is done. What about this one? Can we have 7 doubled? That's 14. Yeah. That is possible. We have a 5, 6, 7 triplet. Interesting. In row 7, which eliminates 5, 6, 7 in the rest of the row. So no 5, 6, 7 here. It's 1. We also have a 5, 6, 7 triplet in box 7, which eliminates 5, 6, 7 in the rest of the box. So no 5, 6, 7 here. It's 2, which leaves that as 4. And this can't be 5 or 7. It's 4. That leaves that as 3. 4 eliminates 4 in the rest of the column. So this can't be 4. That can't be 4. This is 4 and 9. That's 13. Okay. Remaining digits of column 9. 5, 6, 7, 8. Row 9 are 5, 6, 7, 8, 9. No 5 here and no 7 here because of 5 and 7, 9 pair in the column. So 6, 8. And these are 5, 6, 7, 8, 9. Two cannot be here because of 2 in the row. This can then be 5 through 9. Cannot be 9 because we can't have repeats on the cage of digits. This could be 5 through 9 or 2. Remaining digits of column 7, we have 2, 4, 6, 8. Okay. This digit sees both of these cells here, and one of these has to be a 2 as a black hole. So this cannot be 2 here. We know one of these two then has to be a 2. None of these can be 2 here because of it sees both of these two cells that have to have one of them which has to have a 2 in it. Okay. 5, 6, or 7. 9. Where is 9 in the black holes? Cannot be here because of the cage. Has to have a 9 in the non-black hole. 9 can't be here because of the way that this little killer works. 9 can't be here because of the 7, 9 pair here in the column. 9 can't be here because of the way this little killer worked at the teleporting there. So 9 has to be either here or here as the black hole, and they both see this cell. So this cannot be a 9 here, which means this has to be 9 as a black hole, which means this can't be 9 here. So this is 9 as a black hole. 5, 6, 7, 8. This digit as a white hole, again, could be 5 through 9. Okay. 2 cannot be here or here in the central cell. So we have to have 2 in one of those 2 cells there. 9 can't be here. 9 could be any of these, technically. If this is 9, then that would force that to be 9. That is possible. Ones. Okay, where is 1 in box 2? Cannot be here or here because of 1's in the rows. Can't be here or here because 1's in the column, so 1 has to be there. That gives us 8 ones. We know where the last one has to be. It has to be there. 2's can be any of these 3. In column 3. Could be a lot of things in box 2. It's one of these 2 in column 7. 3's. 3 cannot be here or here because of 3's in the row and column. 3 can't be here because of the white hole already having a 3. So 3 has to be there. That means the remaining digits in row 4 are 5 through 9. Okay. 3 then has to be one of those 3 there. 3 has to be one of these 2 there. Three can be any of those 3. That's fine. 4's. 4 in column 3 has to be one of those 3. 4 cannot be here because of the black hole. Already has a 4, so 4 has to be here. That eliminates 4 here and 4 here. Where's 4 in column 7? It has to be here. So that's 4, which eliminates 4 as a possibility here. Where is 4 then in column 3? It has to be there. So that's all the 4's, I think. Yep. 5, we only have a single 5. Great. 6's, 7's, 8's, 9's. We don't really have those either. This can't be 9 because of 9 in the column. So we're going to have to use these now. Ugh. Okay. Okay, this can't be 9 because of 9 in the column. Remaining digits of column 5, we have 3, 5, 6, 7, 8. Obviously, those could be any of those digits. Can we get to 6 doubled? If this is, sorry, 6, yeah. If this is 6, this would have to be 2. Which would mean this could not be 2. So this would have to be a minimum 5 plus 6 doubled on the white hole. So that's 17 exactly. But none of the other 6, where the white holes that 6 can be, match. Or, sorry, can extend, right? Because they would have to just be at the edge of the grid, which is not possible anymore, going down to the right. So this cannot be 6. It has to be 2. That leaves this as not 2. So this goes to here, and then it goes down to here. So this is 4, already 4. These 3 digits must sum to 17 minus 4, which is 13. Okay. Okay, so 17 minus 4 is 13. 13 minus 6 at minimum is 7. So I think this has to be a 2 no matter what. right? 17 minus 4 is 13. Minus 6 is 7. So these two digits must add up to 7 at most. And then it cannot be 3 here and 5. So 5 doesn't work here, so this has to be 2. So this is 2. That eliminates 2 from being here. So where's 2 in column 3? It's there. I think that's all the 2's, right? No, 2 can't be here, so 2 is there. That's 8 2's. So if this is 6, so we have 2, 4, that's 6, plus 6 is 12. That would force this to be 5 if that were the case. Or that's 8, which makes that 2, 6, 14 plus 3. So this is guaranteed to be 3 or 5 here. We're not sure which. Okay. 2 eliminates 2 from being here in the black hole, so this is 5, 6, 7, 8. Okay. These are all unique digits. Does that help any? I'm not really sure. Okay, so this is done. So we have, well, kind of done. We'll give it a pink or whatever. We need to fill out these with whichever digit satisfies that. This digit is the same as that one. So we have this, we can mark that as A, because it cannot be any of these three. It has to be the same as that. So this is A, which is the same as that. Okay. Does that help us any? A is here. So then this cannot be A, because it's a black hole and you cannot have repeats in black holes. So A can't be, this is A, this is the same as that. A cannot be here or here. A can't be in the black hole. A has to be 8. So this is an 8 here, which eliminates 8 in the rest of the box. This can't be 8, it's 6. That means no 6 or 8 here. It's 5, 7 as a pair. 6 eliminates 6 here, so that's 8. And this has to be, again, 2 plus 6 is 8, plus 4 is 12. That leaves this as a 5, which forces this to be 3. So no 5 here. It's 6, 7 as a pair. That eliminates 6, 7 in the rest of the row. So this can't be 6 or 7. It's 5. So no 5 here. It's 6, 7 as a pair. 8 is here. 8 cannot be here because of 8 in the column. This can't be 5 or 8 anymore because of the 5, 8 pair in the black holes. These 6, 7s both see these two cells. And they have to be different 6, 7s because they are in the black. There are no repeats in black holes. So no 6, 7 here, no 6, 7 here. It's 9. So this can't be 6, 7, or 9. It's 5. 9 is no longer available as a white hole. So this can't be 9. This can't be 9. This can't be 9. So this has to be 9. This can't be 9 here. It's 8. That eliminates 8 from the rest of the white holes. And 8 in the rest of the box here. 5 cannot be here anymore because of 5 in the box. This has to be 8 doubled, which is 16. Plus 0 plus 9 adds up to 25. So that's 9, which makes that 7. Where is 9 in column 8? It can only be here. So that's 9 there. So we have this going to the black hole 5, which will then teleport to the white hole, which is 10 in value. 4 plus 9 is 13, plus 10 is 23. We have to get to 11. And this is not going to be 11 by itself. So this cannot be 5. It's 7 as the white hole. This can't be 5 by itself. So this has to be 5 here. So this makes that 6 as a white hole. 3, 2, 1. No 6. So again, this must be 11 for the rest of these digits. So it's 3, 2, 1, 6 plus 5 adds up to 11. So then this is satisfied. Okay. This is satisfied now, and this is satisfied, so we should be able to just do normal Sudoku. No 9s here because of 9s in the row. So therefore, this must be 9 here. No more 7 here because of 7 in the row. Remaining digit in row 1 is a 7. 5 eliminates 5 in the rest of the column. This becomes a 3, 6, 7 triplet, which eliminates 3, 6, 7 in the rest of the box. So this can't be 3, 6, 7. It's 9. And 3 is guaranteed here, which means this can't be 3. So where's 3 in box 5? It must be here. 8 eliminates 8 here. This can't be 8 or 7. So this becomes a 5, 6 pair, which eliminates 5 and 6 in the rest of the column. No 5 here. That's 7, which makes that 5. We have a 3, 9 pair remaining in column 1 because of the 6, 7 pair here. This can't be 9 because of 9 in the row. So that's 3, which makes this 9. 3 eliminates 3 here. This can't be 7, so that's 6, which makes this 7. That leaves it as a 3 there. 7 eliminates 7 here, so it's 6, which makes this 7. 7 eliminates 7 here, so it's 6, which makes this not 6. That's 8. This can't be 6 or 8. It's 7. 6 eliminates 6 here, so it's 8 and 6. 6 eliminates 6 here, so it's 5 and 6. 7 eliminates 7 here, so it's 6 and 7, which eliminates 7 there, so it's 6. This can't be 6 or 7 because of 6 or 7. 6 in the row, 7 in the column, so that's 8. That leaves that as 7. And the remaining digits left are 5 and 8. And that's the solution. Not too bad. Fairly... I mean, I've done actually quite a bit of these white and black hole puzzles. I don't remember who... I think it was... I don't remember who the setter was. I don't want to give false attribution there. But I've done a decent amount of these. So for me, this wasn't too bad. But I could see if you haven't done very many of these, this could be kind of hairy to try to figure these out. So I think hard is appropriate for this puzzle. Very cool. Very clever use of the restrictions. Or not, I mean, it's good use of the restrictions, I would say, in setting up this puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.